Hey everybody, welcome to another con support video. This one's on interpreting graphs of functions. Let's go. So it says the illustration below shows the graph of y as a function of x. Okay. It says this is the graph of a nonlinear function. Okay. So it's a parabola. The y-intercept of the graph is the function value y equals. So that's where it starts here. So the y-intercept is going to be right here where x is 0. What's y? It looks like y is 0. So it says the y-intercept of the graph is the function value y equals 0. So it looks like when x is 0, y is 0. The x-intercept of the graph in order from least to greatest are located at x equals 0. Right there, right? And that's where cross is. And the other one is at 6. Okay, the greatest value of y is y equals, and that'll be up here, 9. It's the maximum value. And it occurs when x is, and that's 3. And for x between x equals 0 and x equals 6, the function value of y is, so from 0 to 6, you'll see that y is always positive. So y is going to be greater than or equal to 0. Okay, because y is always positive between x values of 0 and 6. Okay, it says David wants to rent a bicycle for a couple of hours to explore the city. The price of the bike rental P depends on the time the bike was out. T. The price consists of a base charge of $8 and a variable hourly cost. The graph of the function is shown below. Complete the following sentences below based on the graph of the function. The hourly charge is blank per hour for the first 3 hours. So if you're looking at the situation here, where T is hours and P is the charge, for the first 3 hours, we can see that that is $20, right? So it's going to cost $20 for the 3 hours, and it starts at 8. So that means that the difference is 12. So from 8 to 20, it went up $12 in the course of 3 hours. So that means that the hourly charge is $4 per hour. The rate then drops to blank per hour until the end of the 6th hour. So when you go to the 3rd hour to the 6th hour, we're looking at a change from 20 to 26. Okay, so that's a total change of dollars of $6 in 3 hours. So $6 in 3 hours means you're doing 6 divided by 3, which is $2 per hour. So the rate then drops to $2 per hour until the end of the 6th hour. The hourly rate drops further to blank per hour from 6 to 10th hours. So from hour 6 to hour 10, okay, we have this segment here, and that's going to go from $26 to $30 in 4 hours. So that means an increase of $4 in 4 hours. So that's $1 per hour from 6 to 10th. And the maximum price of the bike rental, which stays constant here, is $30. Okay, so no matter how many hours you take it, which is funny because you could just keep the bike forever then, I guess, right? It's a little silly. But anyways, the maximum price of the bike rental is $30. The illustration below shows the graph of y as a function of x. Complete the following sentences based on the graph of the function. As x increases, as x is increasing, it looks like as x increases, y is decreasing for the most part. So as x increases, y is decreasing. The rate of change for y as a function of x is not constant. It's not a straight line, it's a curve. Therefore, the function is nonlinear. For all values of x, the function value y, for all values of x, y is always up here, right? It's never going to be below this line. So that means for all values of x, the function of value of y is going to be greater than or equal to 0. In other words, the y is always above the x-axis, no matter where you put x. The y-intercept of the graph is the function value of y equals, right there, 0, 8. So y is 8. When x is 1, the function value of y is. So when x is 1, y is 5. Let's see when x is 1, y is 5, right? So that's that. The hang time of a football is the amount of time the football stays in the air after being kicked. Zara kicks a football, and the height of the football above the ground at t seconds is shown in the graph below. Complete the following sentences based on the graph of the function. This is the graph of a blank function, nonlinear. It's a parabola, so it's definitely nonlinear. The hang time of the football is how many seconds? Well, you kick it, up, down. So it hanged for 3 seconds right there. So that's 3 seconds. You can see the t equals 3 right there when it hits the ground. And then it says the football reaches its maximum height when t equals what seconds? So that's the highest point. It was at 11. And what was the x value, or the t value, I should say, 1.5. So when t is at 1.5, it's at its maximum height. Maximum height is about blank meters, so about 11 meters. Yeah, that makes me a little weird, concerned about this round your answer to the nearest whole meter. It looks like it's just the maximum height is about 11 meters. So I'm not really sure what the rounding is. But for t between t equals 0 and t equals 1.5, the height is, okay, so from t equals 0 to t equals 1.5, which is right here in this section of the graph, okay, the height is what? The height is increasing, okay? So basically, this is the part of the parabola where the ball is being thrown wee up in the air. It's increasing in height until it stops increasing, and then all of a sudden starts to decrease. So maximum height was 1.5. So at that point, it hasn't decreased at all yet. It's just stopped, and then it starts to decrease. So from 0 to 1.5 on the t-axis, you have a h-axis that's always increasing. All right, so that's how you do it. Let's stop that.